Hello everyone, this is Maithili working as Assistant Professor in Department of Chemistry, St. Josephs Arts and Science College for Women, Hosur. Today we'll see about halogens. General characteristics of halogens. In halogens, both properties are there. First one is physical properties and second one is chemical properties of halogen. First we will see physical properties of halogens. They exist in all three classical states of matter, solid, liquid and gas. They are available in both the solid, liquid, and gas. Halogens are diatomic when kept under room temperature. In room temperature only, halogens associate diatomic. Halogen like fluorine, bromine, and chlorine are poisonous in nature, each having different levels of toxicity. They are using very careful because they are in poisonous in nature. No halogen is completely colorless. In their solid forms, all halogens have a brittle texture. Second one, this is the physical properties of halogens. Second one, we will see chemical properties of halogens. All halogens are electronegative. The gain of electron very fast, making them most reactive for all chemical elements. Halogens easily dissociate into atomic particles and can combine with surrounding elements to form compounds. Third one, when combined with hydrogen, halogen produce halides which are very strong acidic compounds. Typical to non-metal halogens have very low melting and boiling points. Halogens are poor conductors of heat and electricity irrespective of their physical state. The halogens and chemical properties, these are all the halogens of properties of halogens. Next we will see about electron affinity. Electron affinity is defined as the quantitative measurement of the energy change that results from adding a new electron to a neutral atom or molecule in the gaseous state. The more negative the electron affinity value, the higher an atom's affinity for electrons. The energy of an atom is stated when an atom loses or gain energy through chemical reaction that causes loss of or gain of electrons. Next, we see the oxidation states. First, the oxidation state is assigned to each atom in a compound as an indicator of whether the atom is neutral or electron rich or electron poor. The general principle is that the more electronegative atom pulls the electron density of the bond toward it and thus it is in electron rich, while the other atom is electron poor. Next we will see oxidizing power. The oxidant is a chemical molecule that readily exchanges oxygen or other atom for an electron. One agent in the reaction is classified as an oxidizer if it releases oxygen, acquires electrons or produces hydrogen. As the oxidizer accepts electrons, it gets reduced. However, the reactant passes through the oxidation by allowing the oxidizer to take its electrons. An example of an oxidizing agent is oxygen. A molecule that promotes oxidation by receiving electron becomes reduced, then it acts as an oxidizing agent. A molecule that reduces something by gaining electrons is said to be an oxidizing agent. It's simply tell the oxidation power is the uh, electron gaining or electron reduced is an oxidizing agent. Peculiarities of fluorine. Fluorine is the most reactive and the most electronegative of all elements. Fluorine is a pale yellow, diatomic, highly corrosive, flammable gas with a pungent odor. It reacts violently with water to produce oxygen and the extremely corrosive hydrofluoric acid. It is the peculiar character of fluorine because it's a flammable gas. Its corrosive nature is high. It's with a pale yellow color. It reacts with water to produce oxygen. Its corrosive nature is high only. Interhalogen compounds. Interhalogen compounds are compounds formed when halogen group elements react with each other. In other words, it is a molecule which contains of two or more different elements of group 17. There are four types of interhalogen compounds. First one is diatomic interhalogens. Second one tetraatomic interhalogens. Third one hexaatomic interhalogens. Fourth one, hexaatomic interhalogens. Diatomic interhalogen means AX. Tetraatomic interhalogen means AX3. Hexaatomic AX5 means hexaatomic interhalogens. AX7 means octaatomic interhalogens. Noble gases. Noble gases are also known the inert gases, and aerogens are the elements that belong to the group 18 of the modern periodic table. The elements that belong to the groups are helium He, neon Ne, argon Ar, krypton Kr, xenon Xe, radon Rn. Noble gases. Noble gas, any of the 7 chemical elements that make up group 18 of the periodic table. When the members of the groups were discovered and identified, they were thought to be exceedingly rare as well as chemically inert, and therefore were called as rare or inert gases. Noble gases are always chemically inert compounds. In there are 7 elements. In noble gases, there 7 elements are there. This is all the noble gases. Thank you.